Last class we have seen half subtractor. In this class we are going to see full subtractor. Half subtractor means it is a digital circuit which subtracts 2 bits. Full subtractor means it is a arithmetic circuit or digital arithmetic circuit which subtracts 3 bits at a time. 3 bits at a time. Okay. 3 bits, that means we are taking ABC. Okay. Somebody will say this is a previous one, C in just like. Okay, but anyhow C is an input. Therefore ABC is the 3 input. And subtractor will generate 2 outputs, which is a difference output and borrow output. Both are same. In this half subtractor and full subtractor, both the outputs are same. One is difference output, another is borrow output. Inputs are 3. That is the difference. Okay. And last class I told you how to subtract 0 minus 1. Okay. That means 1 from 0. That is you have to remember and you have to apply that one here. Okay. Here what you do is you subtract A minus B and then minus C. Okay. Therefore I will do it carefully. You please listen. Now A minus B means 0 minus 0, 0. Then 0 minus 0, 0. Therefore difference is 0. There is no borrow. Okay. And here 0 minus 0 is 0. And 0 minus 1. That is you have to remember. When there is a 0 minus 1, always there will be a borrow. Because here if you subtract 0 minus 1 means it is equal to 2 minus 1. Already I told you how. Okay, in the half subtractor I told you. Therefore it is 2 minus 1. Therefore difference is 1. You are borrowing. Therefore borrow. Always 0 minus 1 means borrow will come. Okay. Now 0 minus 1 or 2 minus 1 you can say. Okay. That means 2 minus 1. That means you are borrowing. Therefore put borrow. Okay. 2 minus 1. How much? 1. Okay. And 1 minus 0. Therefore 1. Okay. Therefore borrow 1. Difference 1. And here 0 minus 1. Therefore borrow is there. Borrow is there. 2 minus 1. Therefore 2 minus 1 is 1. Therefore borrow is there. 2 minus 1 is 1. And 1 minus 1, 0. Therefore difference is 0. You are having borrow. And here 1 minus 0 is 1. And again minus 0. Therefore difference is 1. And there is no borrow. And here 1 minus 0 is 1. And 1 minus 1. That means there is no difference, there is no borrow. Therefore 0, 0. And here also 1 minus 1, 0. And 0 minus 0, 0. Therefore there is no difference, there is no borrow. And here you have to think. Okay. 1 minus 1 is 0. Okay. And 0 minus 1, that means 2 minus 1. Therefore difference one will be 1 and borrow will be 1. Okay. Only thing you have to remember, if 0 minus 1 means borrow definitely will come. Okay. Now we prepared the table. Now we have to write an equation. Before writing equation, okay, it is a, let us go for a K-map. Because when more terms are there, in a half subtractor we simply written the equation. But here more terms are there. Therefore before writing expression we have to go for a K-map. We have to simplify and then we can go for an equation. Here also it is possible. Okay. Here what you can do, A bar minus or A complement, B complement and C. This is the minterm for this. And for this A complement, B, C complement. Okay. 4 terms will be there. Because how to write the equation? We have to write equation for the one only. Therefore here 1, 2, 3, 4 ones are there. Therefore 4 minterm will be there. Okay. I directly go for the K-map. Here say it is a 3 variable. Therefore I have drawn 3 variable K-map. And I have substituted also. Okay. In order to reduce the time for you. Okay. Now I have substituted. And these terms are not there. Therefore you simply put 0. Okay. Say by looking this, okay, alternate terms are there. 0, 1, 1, 0, just like alternate terms are there. Okay. That means it is simply XOR gate. It's simply XOR gate. Therefore, your difference will be A XOR B XOR C. In the full adder, I have solved this equation by normal method, not by this CAMAP method. You can compare that and this. Okay, both will be same. Okay, we will be having the same minterm for the sum. Okay, in the full adder, we will be having the same minterm, and I have solved that by normal equation method. Now, CAMAP method. CAMAP, if you go for this, then it is a or which gate? XOR gate. And now we have to go for a borrow. Now for the borrow, again you have to go for a CAMAP. Okay. If you go for a CAMAP, okay, then what is this? Here A bar, B bar, and A bar B, A B, and A B bar, C bar, C. Okay. That means here A bar, B bar, C. That means here. Okay. That means here this one I am writing here, and this one A bar, B, C bar. That means here. Okay. And this one A bar, B, C. That means A bar, B, C. And this one both are 0, and this one A, B, C. Therefore this is A, B, C. Therefore these are all 0. Okay. Now you have to go for combination. Here quad is not possible. Therefore we have to go for a pair only. That's you already know how to make this. And this will be one pair, and this will be another pair, and this will be another pair. Okay. Say I have made differently. One is ellipse, another one is dotted one, another one is a rectangle, just like you have to go. Okay. Now here this is for this ellipse. Okay. What will be having? C is common and A bar is common. Therefore your borrow output is which one? Here A bar is there and C is there. Therefore A bar C. Okay. And for this plus A bar B. And for this it is BC. Therefore plus BC. Okay. Now this is your difference equation. This is your borrow equation. Two equations you got. Then next step, simply you have to go for a circuit design. I erase this, and you are familiar with this. How to implement this? Okay. And just simply you go for 3 input, A input, and its complement, and B and C. Okay. Here I have not drawn B complement, C complement, because in this expression only A complement is there. There is no B complement, there is no C complement. Therefore there is no need. And here XOR gate. You can go for XOR gate simply. Okay. Instead of going for a basic gate, you simply go for a XOR gate. That means 3 input XOR gate you can directly draw. Okay. That means A XOR and B XOR and C XOR. This is your difference. Okay. Now for this borrow, you can go for 3 AND gate. Okay. And that means A complement and C, and A complement and B, and B and C, and you have to go for a OR gate. 3 minterms are there. For the 3 minterm, that means product term, 3 AND gates, and for adding this, you have to go for a OR gate. Okay. Now this is your borrow output. Okay. Now see the difference. This will be one question in university. They will ask, how will you convert a full adder into a full subtractor? What is required? Okay. In full adder, you had 2 outputs. One is sum output, another is carry output. Okay. In the sum, A XOR B XOR See, this is the output for the sum. For the carry AB plus BC plus AC. Okay, this is your carry output. See the difference here. In the difference A XOR B XOR C. Therefore, both are same. Okay, both are same. For the full adder, sum, and for the full subtractor, difference. Both are same. And for borrow A bar C, here AC is there, and BC is there. Here AB, here A bar B. Only one NOT gate is required. Okay, only one NOT gate is required in order to convert a full adder into a full subtractor. Okay, in exam they will ask simply, how will you convert a full adder into a full subtractor? Then if they ask, you have to see how much marks they are giving for the question. Okay, if they are asking for 2 to 3 marks, then you have to go for these two expressions, and these two are differing by a complement only. Therefore, by putting extra one NOT gate, we can simply convert a full adder into a full subtractor. You can write. Okay, this is the two comparison also. Okay, I think hope you can understand this. If you have a doubt, please put on the comment, and please subscribe and put comment in your comment box. Thank you.